All right. Hi, you guys. I'm going to finish making the key for this Unit 2A bonus assignment. So this was the first page. If you only needed to review classification of matter, you can just watch that video. If you need to review how to write names or formulas of chemical compounds, that's the part we're going to do right now. So this is page 2. You definitely need to have your BFF or your periodic table handy. Okay, and let's just go through these things and name them. Okay, so the first one, this first column is just here to try to help you remember the rules or remind you to figure out what kind of compound you have, because that's going to affect how you name it. So ionic or molecular, ionic or covalent. So the first thing you have to do is ask yourself, is there a metal? Okay, because if there's a metal, you name it a certain way. In this case, yes, sodium is a metal. All right, sodium is right here. That's a metal. So in that case, it's ionic, and we would follow the ionic naming rules. So we would just say sodium, and then S is sulfur. It's right here, and then we would change the ending of sulfur to sulfide, S-U-L-F-I-D-E. So the second element's name, if it's just a single element, gets changed to IDE. All right? This one, calcium Ca3PO42. So is there a metal? Yes, calcium is a metal. So that means it's ionic. All right, calcium is right here in the metal part of the periodic table. So we would call that calcium. We're going to follow the ionic naming rules. Now we have PO4 with a 2 on the outside. So another thing to remember is that these things are always binary, which means there's always two parts. Here's the first part, calcium. PO4, we have phosphates and oxygen, so that's kind of a clue that that's a polyatomic ion, and you would have to find its name back here. So here's PO4. Its name is phosphate. So we call that calcium phosphate. All right? Okay, the next one is FeCl3. Is Fe a metal? Ask yourself, is it a metal? The answer is yes, it's a metal. That means it's ionic, okay? Then you need to say, oh, well, what kind of metal? Well, in this case, it's a transition metal. So Fe is right there. The middle chunk of this periodic table are the transition metals. And when you name something containing a transition metal, you have got to have a Roman numeral in the name. All right, so in this case, we have to figure out which iron we've got. We could have either iron +2 or iron +3. All right, so the way to figure that out is to look over here. We got iron, and we have 3 chlorines. Based on that formula, charge on chlorine right here is a -1. So -1, -1, -1. So that whole side adds up to a -3. We have 1 iron, so that has got to be a +3 iron, because ionic compounds have to be neutral. Their formulas have to add up to 0. So in my name now, I need to include the charge of that metal in the name. So I would say, iron, Roman numeral 3, and then chlorine becomes chloride. All right, so that one was a little tricky, because if you have a transition metal, you have to put a Roman numeral in the name. And that Roman numeral 3 tells me that that iron has a charge of +3. Okay, here we have H, capital I. Okay, do we have a metal? No, we don't. H is not a metal. But any formulas that start with H tell you that that is an acid. All right, oh, this should say acid up here, sorry. All right, that is an acid. Okay, the naming rules for acids are back here. In this case, iodine becomes iodide. So the ending of that I is ide. So this acid becomes hydroiodic acid. Hydroiodic acid is the name of that. Okay? All right, the next one. Ooh, we have another H, starting with H again. That's an acid. Okay? In this case, we have that thing right there. We have H with that thing. So we got to figure out what ClO4 is. I'm going to write this up here. ClO4. So we got to find it. That's an oxygen. So we have an oxyacid. So we're using one of these polyatomic ions. So let's find ClO4. Oh, there it is right there. ClO4 is called perchlorate. That ends in ATE. Then you look over here. Polyatomic ions that end in ATE. That acid becomes ic acid. So perchlorate becomes perchloric acid. So perchloric acid, because ClO4 minus 1 equals perchlorate ion. 8 becomes ic. Ic, I ate it. All right, NaOH. All right, is there a metal? Yes, Na is a metal, so this is ionic. OH is a polyatomic ion. It's on the back. OH minus 1 is hydroxide. It's right there. So we would just name this sodium hydroxide. All right. H2O. Is there a metal? No, there's not a metal. Okay? No metal. Therefore, it is covalent, otherwise known as molecular. And obviously, we know that the common name for this is water. But we're going to use the prefixes to name it if we have something that's covalent, otherwise known as molecular. So look over here. All right, so this is when you have a non-metal plus a non-metal. H's and O's are both non-metal. So H2 is di. We have one oxygen, so that's mono. So 2 hydrogens becomes dihydrogen. We have one oxygen, so we say mono oxide or monoxide. You can drop that middle O if you want to. All right, so you first have to figure out if you have an ionic compound or a covalent compound. If it's covalent, we use those prefixes. Okay, and that should be pretty simple, hopefully. All right, let's do this one. OF2. Do we have a metal? No, we don't. O and F are both non-metals. All right, so we're going to use our prefixes again. Non-metal plus non-metal. So OF2, we have one O and 2 F's. In this case, we don't say mono. This is covalent. We just say oxygen. And then we say di, because there's 2 fluorines right there. Difluoride. The ending of the second thing, it's changed to IDE. And we don't say mono if we have one of the first element. We only say mono if we have one of the second element. All right, Cu2O. Do we have a metal? Yes, we do. Cu is copper. Copper's a metal. That's ionic. All right, let's find copper. It's right there. Oh, look at that. It's a transition metal. So we got to have a Roman numeral in the name. So we have to figure out the charge on that copper. It's either going to be, if you look on the back here, it's either going to be copper plus 1 or copper plus 2, and we have to figure it out. All right, this formula, I have 2 coppers and 1 oxygen. I always look at the anion to figure out the charge of my transition metal. So oxygen always is going to have a charge of -2. Here's oxygen. Here's its -2 charge, so that's a -2. Ionic compounds have to add up to 0. So each of those has to be a +1, because now +2 and -2 are going to cancel. And the name of this is going to be copper, Roman numeral 1, oxide. Okay? All right, I think I'll do the next part in the next video.